Um, uh, I'm trying to figure out how to so I had this problem in my math test that I didn't really understand.
Okay.
So it was like so it's x to the third power minus 8, and then there was a lot more involved, but I don't really remember it. But I didn't know how to she said
Well,
there was a way.
what is that called right there?
I have no idea.
Difference of perfect cubes. In other words, x cubed is a perfect cube, and so is 8. 8 is 2 cubed. So
Yeah.
you have to draw in your formula if you have a cubed minus b cubed. In fact, let's go over all of these because there's a pattern to all of them. Let's start with difference of perfect squares. How does that factor? The trick is to know how they factor. Do you know how difference of perfect squares factors?
No, I don't.
It's a minus b times a plus b. Okay? So if I had x squared minus 16, that would factor into x minus 4 times x plus 4.
Okay.
Okay? Now, there is no sum of perfect squares. There is no factoring a squared plus b squared. But there is a difference of perfect cubes and there is a sum of perfect cubes. Difference of perfect cubes means this, and that factors a minus b times a squared plus opposite sign of this, ab plus b squared. And then there's also a sum of perfect cubes. And obviously they expect you to know these if you're getting problems like this. Now there's a pattern to all of these. Once you memorize the pattern, you won't have any trouble memorizing each one. Notice that the first factor on difference of perfect squares is the same sign as we started with, and it's linear. It's not a squared, it's a minus b. Difference of perfect cubes. The first factor is the same sign, and it's linear. So you have to memorize that one. A squared plus AB. Notice that that sign is opposite to this sign. Whatever this sign is, this is going to be opposite on the middle term. And finally, we have sum of perfect cubes. First term is linear, same sign as what we started with. Second term is exactly the same as the above, only the sign is opposite the linear term. Hold on, didn't mean to erase that. So let's go over some. Let me give you some and see if you can figure out how to do them. Let's start with difference of perfect squares. Factor that for me.
So it would be 4.
No, the first term is the square root of that. The b is the square root of that.
Oh, okay. So it'd be 2.
What's the square root of 4x squared?
Oh, 4x.
4x squared. What's the square root of that?
2x, I mean.
Okay. So 2x goes there. And I'm just going to do the first term here because that's another thing that makes it easy. What's the next one? We know it's a negative sign, right?
Yeah.
What goes here?
5.
And the second part is exactly the same, only it's the conjugate. So it's 2x plus 5.
Okay.
Okay? Now, difference of perfect cubes. This problem that you gave me is the difference of perfect cubes.
Uh-huh.
So how would that factor based on what I have drawn there?
So it would be x minus 2
Correct?
with x squared plus
This sign is always opposite the first sign.
2x
Correct?
plus negative 64.
No,
No.
we're squaring 2.
Oh, negative 8. No, negative 4.
Positive
Plus.
4. In both cases, it's plus b squared.
Uh-huh.
Okay? In other words, the only difference between this and this is the sign of the middle term. Everything else is the same.
Uh-huh.
The only difference between this is the sign of the middle term. So there's a pattern between difference of perfect cubes and sum of perfect cubes that you want to be able to know. So anyway, this part of your problem, the x cubed minus 8, factors into this. And then it was probably being divided by an x minus 2, my guess, times something else. I don't know. One thing is that when you do difference of perfect cubes or sum of perfect cubes, this quadratic is never factorable easily. In other words, you can always factor quadratics with the quadratic formula, but don't waste your time trying to factor that further. It won't.
Okay.
Unless you bring in imaginary solutions and all of that. Just to let you know, because I've spent a lot of time after factoring difference of perfect cubes trying to figure out whether that quadratic was factorable, and it never is. At least not into a, x minus 2 times x plus 3 or something. All right, so we've covered the 3 biggies that you're expected to know. Now, why is there no sum of perfect squares? Because if it's an even exponent, you never have the sum. If it's an odd exponent, you can have the difference and the sum. And that counts all the way up. In other words, there's no sum of perfect 4 quarters. In other words, a to the 4th plus b to the 4th does not factor into anything. Just like a squared plus b squared. But as long as you have odd exponents, both of these can be factored. In other words, if I had an a to the 5th minus b to the 5th, or an a to the 5th plus b to the 5th, I can factor those.
Okay.
Okay. So hopefully that has solved some of the problem on your end. What else
Um,
you want to cover?
we're working on conics right now, which are like fairly easy for the most part.
Conics, okay.
Could you explain to me how to graph them though?
Sure. There's 4 conics: parabolas, circles, ellipses, and hyperbolas. Have you covered all 4 of them or just some of them?
No, we've covered all 4 of them.
Okay.
And we've covered just how to put them in standard form, which is like pretty easy. You just have to complete the square and add it.
Correct.
And then,
Correct.
but we haven't gone over graphing yet, so I just want to get an edge on that for school tomorrow.
The key things are the standard formula for each. So let's talk about parabola, and I'll graph it for you also. For the parabola that you've worked with for years is this one. okay? That's just a vertical parabola, points up, put a negative sign on it, and points down, and so forth. Well, when you get into conic sections, they change the general format on you. It's no longer that. It's now 4py, and tell me if I'm wrong here, but this is, I think, what you're getting, equals x minus h squared plus k. That's for a vertical parabola, up or down. Well, when you get to conics, they also have horizontal parabolas, where you're just going to switch the y and the x. In other words, the 4p goes in front of an x, and on the other side you have y minus k squared plus h. And this p is what they call a focus. In other words, when you get to conics, parabolas have a lot more going along than you learned the first time. A parabola has something called a focus that's inside the parabola, and it also has something called a directrix, which would be an imaginary line that you don't see when you're looking at the parabola. And the actual definition of parabola is the set of all points that are equidistant from the focus and the directrix. In other words, if I look at a point right there on my parabola, this distance is the same as that distance. If I look at a point down here, that distance is the same as that perpendicular distance. If I look at a point way up here, this distance is the same as the perpendicular distance to the directrix. So when you're talking conic sections, you have these things called focus and directrix that you never had to worry about when we were just talking parabolas. And that's why they changed the general format on you, is that we never used to have this thing called p. The old format for a parabola was y equals a times x minus h squared plus k, and that was it. That was the only formula you had. And that gave you everything you needed to know about parabolas back then. But now in conic sections, you need to know these things, focus and directrix. And so the formula is similar, but instead of the a, they put 4p over here. And that p, whatever it comes out to be, is the distance from the vertex to that focus. It's that distance right there is what p is.
And then the directrix is the same distance down.
Exactly. Whatever positive p is up, negative p gives you the directrix, unless it's a parabola like this, and then your focus is there and your directrix is there. In other words, the directrix is always outside the curvature, the focus is always inside.
And so how would you find the focus point then?
Well, depending on the equation they give you, you can figure it out by just solving it. In other words, they always give you enough information. If they give you the equation, let's say that I told you that 4y was equal to x minus 3 quantity squared plus 5. Okay?
Okay.
That's in this exact format. What's p? In fact, let me graph this. I'll graph it. So you can, first of all, we don't want to start with p, we want to start with the vertex. Where's the vertex? What's h and k?
It's 3, 5.
Okay, so there's the vertex. Okay, and we know it opens up because there's no negative signs in front of anything. Now the question is where is that focus? We know the coordinates on that are 3, 5, but what are the coordinates on the focus? Well, put this equation that I gave you in the exact format. So what does 4p have to be?
Oh, so you just plug in 3, 5 into the equation and
Not
then you
3,
should...
5. No, no. What you want is to figure out what 4p is. What you really want is to figure out what p is. But 4p is the coefficient on y, and the coefficient on y is 4. So I can say 4p equals 4, which makes p equal to 1. Which means this focus is at 3, 6. And the directrix would be 1 down. So that directrix is y equals 4. Okay? So basically what you do is once you get it in the format that you're supposed to have it in, then you set the coefficient equal to 4p. Now, hold on 1 minute. Make sure I haven't made a mistake in that formula. I hate to give out incorrect information, so let me just look at it and make sure that I gave it to you correctly.
Okay.
Hold on. X squared equals 4py would have is what the formula is if it's at the origin. Oh, this book's not going to give it to me, of course. The only part that I wasn't positive with was where that K belongs. Yeah, I'm looking at the wrong book. Book I have in front of me is an Algebra 2 book. Is that what you're taking, is Algebra 2?
Yeah.
Okay, interesting. You may not actually encounter the H or the K. In other words, when I looked at my Algebra 2 book, the only kind of parabolas it was talking about were ones whose vertex was at the origin. And if that's the case, then H and K are 0, and you get 4py equals x squared.
Uh-huh.
In other words, it's kind of the easy situation.
I definitely haven't been dealing with equations like that, though.
You have or have not?
I have not with the origin with vertex at the origin.
Okay. Well, regardless, let's talk about a horizontal parabola, because you never dealt with a horizontal parabola before conic sections, because they're not functions, and they tend to deal only with functions. But if I have x equal y squared instead of y equal x squared, I have a parabola that looks like that. Opens to the right. Okay? If I have a negative sign in front of the y squared, it opens to the left. Same as up and down, only it's right and left. And notice that it's x equal y squared, not y equals x squared. And also, the 4p goes in front of the variable that is not being squared. In both situations. Notice in the vertical parabolas, the 4p goes in front of the y. In the horizontal parabolas, the 4p goes in front of the x. So let me give you one here. If I said 8x equals negative y squared, that's a horizontal parabola. Because of the negative sign, I know it opens to the left like this. I know its vertex is at the origin. What is p?
2.
So it's in a way it's plus or minus 2. In other words, if you do the math here, you're going to end up having to, well, It's not really plus or minus 2, excuse me. It's negative 2. Because if I divide both sides by this negative sign, I get negative 8. And negative 2 is the right direction. I want to go to the left to find that focus, because it's got to be inside the parabola. And of course the directrix is over here, and the equation of this directrix is x equal to, not y, because it's a vertical line, not a horizontal line. So that's parabolas. Now, conic sections is an hour and a half, maybe a 2-hour tutoring session. As you can see, we've spent 24 minutes just talking about parabolas. And we still have circles, ellipses, and hyperbolas. Real quickly, let me just draw them. Let me give you the standard general formula for a circle. X squared plus, and I'm going to give you the general formula just for circles at the origin.
Okay.
For 2 reasons. The interest of time. R is the radius of the circle. So a circle equation is really simple. If I said x squared plus y squared equals 16, I'm talking about a circle whose center is at the origin and whose radius is 4.
Okay.
Okay. Now let's talk about an ellipse. An ellipse that's at the origin. This is the equation. Notice that it's significantly different than a circle. It's got an A and a B in it. Well, A you can kind of think of as the long radius and B as the short radius, even though they're not called radiuses. Okay, but A is the distance from the center of the ellipse to the major vertex right there. And B is the distance from the center of the ellipse to the minor vertex. So B is always less than A. And that's a horizontal ellipse. If I have a vertical ellipse, then the A comes under the Y term. And that would graph like this. Notice why the A is under the Y term, because the A is the longer radius.
Is A always the longer radius?
For ellipses it is. For hyperbolas, no. But for ellipses, yes. A, by definition, has to be greater than B. And if you have a vertical ellipse, then that's why the A goes under the Y, because it's along the vertical axis. And the B goes with the X because it goes along the horizontal axis.
Okay.
Now, an ellipse has 2 focal points. Right there and right there. And there's an equation that says c squared equals a squared minus b squared, with c being the focal length from the center of the ellipse to the focus. In other words, c is this distance right here, from the focus to the center. And there's 2 of them. There's going to be a plus and a minus. Plus c is going to go to the right, the minus c is going to go to the left.
Okay.
Real quickly, let me do hyperbola. It's the only one left. Hyperbola is x squared over a squared, but it's a minus now. Y squared over b squared, and it's still equal to 1. And there's 2 kinds of hyperbolas. There's the horizontal kind And there's the vertical kind. In other words, rotate this picture by 90 degrees and you'll be looking at a vertical kind.
And it's the same concept with ellipses where it's x over b squared for the vertical hyperbola?
Not quite. No, actually it isn't. Unfortunately, it's not the same. A hyperbola has an imaginary rectangle, kind of like a directrix, only it's an imaginary rectangle. And the purpose of this rectangle is if you draw the diagonals of that rectangle, you will get the asymptotes for the hyperbola. In other words, as we go to the right, this hyperbola gets closer and closer to those diagonal asymptotes. Never quite touches them, but approaches them. Okay?
Okay.
So that's the purpose of the box. You don't see the box, but the A is always the distance from the center to that vertex. That's A. B is the distance from there to there, B. There's also a C, and unfortunately its equation is also different. It's A squared plus B squared. It's like the Pythagorean theorem, as opposed to ellipses where it's A squared minus B squared. And C is a focal point inside the hyperbolas, like that. So C is always going to be greater than A for hyperbolas. Whereas with ellipses, C is always less than A. And that's really all, I mean, that's the basics of conic sections. That's your 30-minute course. And those are only conic sections that were at the center, whose center of the conic section was at the origin. The moment you move it from the origin, then each of these becomes x minus h quantity squared and y minus k quantity squared, where h and k are the center of the hyperbola or ellipse or circle or parabola. If the vertex is not at the origin, then you have an h and a k. And like I said, you may not get introduced to those this year. I couldn't find them in my Algebra 2 book. So you may not get those until you get to pre-calc.
Okay. So next year?
What's that? Yeah, that should be next year for you. You should probably take pre-calc trig next year.
Yeah, I think so.
And you'll get more conic sections then, and you'll definitely get the x minus h quantity squared when you get the conic sections there. But they're fun. I mean, they're hard because you got to memorize those 4 general formulas, and you really got to memorize them and understand them. But once you do, it's pretty challenging and fun to do problems involving conic sections. You have to have those general formulas memorized properly.
Okay.
There's no substitute for it. Okay?
Okay. Well, thank you.
All right, Jake. I will talk to you next time.
All right. You have a good rest of your day.
You too. Bye-bye.